Minute answer drills are quick conceptual quizzes. If you're interested in a particular question within the minute answer drill, watch the bottom left-hand side of the screen for that number to come up. We're going to take it from the top. Okay. A certain facility has a design capacity of 2,500 units a day and an effective capacity of 2,225 units. Name one potential determinant of effective capacity. This particular problem could have lots of different answers, but the key is you're looking for a reason for the difference between 2,500 and 2,225. Maintenance might be one of them. Routine work breaks. Any credible reason that there's a little gap between the theoretical maximum of the facility and what you can reasonably expect out of it every day. All right, next question. What is the volume of output that results in the lowest average unit cost of a production facility known as? That is its optimal meaning best, operating level. The ironic thing is that the optimal operating level for a facility is not necessarily the same thing as its effective capacity, but I digress. Let's look at the third one. All right. If increasing the volume of production is likewise increasing the average cost per unit produced, the system is suffering from what? This is a diseconomy of scale. Diseconomy of scale or diseconomies of scale? Oh, right. To go back to the question before, you have an optimal operating level. If you increase production beyond that, you push beyond that level, you move into diseconomies of scale. So there's a link. Anyway, next question. Mirrors are sometimes placed in busy lobbies, waiting areas, and on elevator doors. Their purpose is often to make time pass faster for people waiting in front of them. What is the psychological principle that best describes this distraction? Yes, anytime you can distract somebody from the fact that they are having to wait, their impression of how long they waited will generally be somewhat kinder or somewhat less. If that delay is only going to be like really short, like for a few seconds, one of the things that seems to reliably distract us, at least for a few seconds, is our own image. So see if you can work mirror into the decor somewhere. Anyway, next question. What is the body of knowledge concerning mathematical modeling of waiting lines called? Queuing theory. That is the name for the body of knowledge concerning the mathematics of waiting lines. Queue being another word for waiting line. Okay, next. You are observing a line of people at an ordering counter at a campus coffee house. All right, there's at least 15 people waiting to order. Suddenly you notice 2 people walk in the front door of the coffee house, stop when they see the other 15 people waiting, shake their heads, turn around, and leave. Exit the coffee house immediately. What have you just witnessed is an instance of customer impatience best known as... That behavior was balking. Yes. If a customer shows up, is a random arrival, looks at the line and does not join it, that was the key with this particular scenario with the coffee house. They looked at the line, shook their heads, did not join it, and disappeared again. That is known as balking. It is a phenomena that, if present, can essentially limit the length of any line. Now, let's look at the, next question. What does queue discipline determine? Okay, that is an important vocabulary term. Queue discipline determines the order that arrivals are served. The most familiar Q discipline rule, because it will be a rule for placing things in order, the most familiar Q discipline rule to us is first come, first serve. I'm served first because I arrived first. That's not necessarily, however, the only rule. You know, there actually are lots of other rules. Could be shortest processing time. Okay, anybody who's going to be quick can go first, or emergencies first is another logical one. Anyway, that's Q discipline. Now, next question. The economic model of waiting lines minimizes the combined cost of waiting and the what other cost? Okay, economic model implies trade-off. Trade-off between what? The cost of waiting and the system cost, or cost of system capacity, right? In the economic model, let's see, if you want to maximize service, you would maximize the capacity, but that would maximize the expense of the capacity, but that would minimize lines and minimize the waiting expense. If you want to minimize the waiting expense, then that's what you would do. But if you're worried about capacity cost, you minimize that by just having a few servers. Well, okay, that's fine, but that's going to make the lines grow longer, and then that's going to maximize the cost of waiting. Anyway, trade-off. Two things work against each other. All right, next. In an MM1 system, if the customer arrival rate increases while service times remain the same, what happens to the waiting line for that service? What happens to the service's utilization rate? Okay, no fair. This particular one is two questions. Okay, first, what has happened? Let's look. The customer arrival rate increases, the service times remain the same. What's going to happen to the waiting line? It's just logic. Waiting line grows longer. More people are showing up, but they're not serving any faster. The line's going to grow longer. What happens to the services system's utilization rate? Utilization, that's what I was trying to write. Utilization increases. Now, we can demonstrate this mathematically, but it's probably easiest just to remember as common sense. The number of people showing up is increasing. The rate at which they're serving is not increasing. The line's going to grow longer. More customers are showing up. The service system's going to get busier, right? So utilization will also increase. All right, next question. When an arriving customer leaves after joining an existing line for service, but before being served, this behavior is called what? Okay, leaves after joining the line, but before being served, that is known specifically as reneging. What's the difference between that and that business with the coffee shop, and balking? Oh, balking's where the customer looks at the line, says no way, and leaves before they join it. Reneging is when they've been in the line, so they've been part of its length for a while, but then they kind of bail out of the line because they get tired of waiting. Okay. What's the next question? What type of capacity assumes the ideal operating conditions? And the key word there is ideal, because that is what specifies design capacity. Design capacity is the theoretical maximum that the system can provide, so it's typically assuming ideal conditions. All right, next question. What type of capacity assumes normal operating conditions, including breaks for maintenance, etc., what you can normally expect out of a system? This is the companion of design capacity known as effective capacity, which you can reasonably expect out of the system in any given day. Okay, now, next question. What is idle capacity maintained to absorb unexpected demand called? Idle capacity absorb, that is capacity cushion. Capacity cushion is a little bit of extra ability that you maintain in your system because just in case it's going to be really, really busy, you'll be able to answer that demand.